Welcome to School of Civil Engineering. This is Hedaetullah with another new video. In this video, I will discuss with you about column design rule. Okay, so before design a column, we need to know about some important parameters that are really important for column design, and according to some design codes, I will try to discuss about that. So let's start. And if you're new here, you can watch our previous video. There have almost huge amount of basic civil engineering related video and also for software related video. So if you're new here, you can watch that. I think it will be very helpful for you for your practical life also. So let's start. First of all, we will see about strength of concrete. So compressive strength of concrete shall not be less than 17 megapascal. That means our 18 days compressive strength couldn't be less than 70 megapascal. Clear? Then if we go here, that how can we calculate our elasticity modulus? Modulus of elasticity for concrete shall be permitted to be taken as WC to the power 1.5 0.04 3 root over FC prime. Here FC prime in megapascal for value of WC between 14002 to 2560 kg per meter cube. I mean for every unit cubic meter, if the weight of the concrete is 1444 to 2560 kg, then this is the equation to find out our elasticity modulus for concrete. And for normal concrete that we use generally, I mean our 150 pound per CFT, then I mean per cubic feet, then we can use that equation here. FC prime is in megapascal. Okay, 4700 root over FC prime. Then design strength of reinforcement. So according to as concrete strength, we'll also see about design strength of reinforcement. So here design strength of reinforcement represented by the value of Fy used in design calculation shall not exist 550 megapascal. Okay, I mean our design strength, I mean our yield strength of our steel couldn't be exist 550 megapascal without any special case. Okay, so I mean it's almost 82 psi, sorry ksi, 82 ksi. Then for transfer reinforcement, Fy maybe exist 40 megapascal. I mean for a transfer reinforcement like as triver or spiral, like that types of reinforcement, it can be exist, I mean it can be more than 420 megapascal. Then modulus of elasticity, we all know that the used reinforcement as river in our building, its modulus elasticity is almost 2 lakh megapascal. Okay, 2 lakh megapascal. After that, strength reduction factor. So for compression control section, I mean column is a compression control section, member with spiral reinforcement conforming, its phi, I mean its strength reduction factor will be 0.75, and other reinforced member will be 0.65. I mean here other reinforcement member means for tie or other. Then limits of reinforcement for compression member. The area of longitudinal reinforcement AST shall not less than 0.01 gross sectional area of concrete or more than 0.06 gross sectional area of concrete. Okay, that means cannot be less than 1% and cannot be more than 6%. Okay, cannot be less than or cross area, minimum area of steel shouldn't be less than 1% and more than 6%, and sometimes it's allowable till 8% according to ACI code. Then minimum number of longitudinal bar in compression member shall be 4 bar. Within this is the minimum longitudinal bar, main bar, our main vertical bar for column. It's 4 bar within rectangle or circular tie. Okay, rectangular, circular tie, 4 bar, and this for a square or rectangular shape of column. Then bars within rectangle ties, I mean it's 3 bar within rectangle ties, 3 bars within rectangular ties. Then this is the number of bar, this is the minimum bar. Okay, this is the number of bar here using its minimum. So after that 6 bar for enclosed by a spiral conforming. Okay, so first condition was 4 bar within rectangular or circular tiles. If the tiles are rectangular or circular, then the minimum longitudinal bar will be 4 bar. Then for rectangular ties, triangular ties, it will be 3 bars, and 6 bar for a spiral conforming. Okay, then the used moment of inertia for column, it should be 0.7 70% of gross moment of inertia or main moment of inertia of the section. This is according to ASCE and also ACI. Then for compression members, the clear distance between longitudinal bars shall not be less than, for compression member, the clear distance between longitudinal bars shall not be less than 1.5 bar diameters. I mean the 1.5 times of used diameter, or 40 millimeter, 1.5 inch. I mean the minimum should be 40 millimeter or 1.5 inch, and 1.33 times of maximum normal size of coarse aggregate. So they have three conditions. First of all, 1.5 bar diameters, 40 millimeter or 1.5 inch, 1.33 times of maximum nominal size of coarse aggregate. So here the important thing is you have to consider from here the maximum one. Okay, suppose you are using 10 millimeter bars, or you are using suppose 20 millimeter bars, then your spacing will be 1.5 times into 20, I mean 35. That means it's not fulfilling the 40 millimeter. So like that way, then you have to use 40 millimeter. So like that way, the maximum spacing you have to consider. Okay, then minimum cross sectional dimension of column is 19 into 12 inch or 225 millimeter into 300 millimeter, which is minimum recognized size. Actually you can use any size, but this is the minimum recognized size from the experienced engineer. Then required reinforcement for column, minimum 1% and maximum 8% of cross sectional area of column. So previously I have already discussed about that. it's 6% is best maximum, but sometimes it's used 8% according to ACI. So thank you very much for watching. If you're new here, like our channel, actually this is your channel, and also share that video with your friends that are studying in civil engineering. Also leave a comment, your own like and on comment inspire me for the next work. And also if you're new here, stay with us for the next update. So thank you very much. Stay well, stay connected till next video.